just like derivatives, we can also use integration. So let f of x equal to 3x minus 2x squared plus 5x cubed divided by 3 factorial. All of this. So we have 1, 2, 3, 4 terms and a general term. We want to write the first 3 terms of the general term in series for f prime. So the first part here, we're going to do derivatives. So f prime of x is equal to the derivative of 3x, 3, minus the derivative of 2x squared, plus the derivative of 5x cubed over 3 factorial. I know we're going to multiply by 3, but we have a 3 factorial in the bottom, so I'm going to go ahead and simplify that. So we have 5x squared over 2 factorial. And then the same thing, we have minus 6x to the 4th divided by 4 factorial. We're going to multiply by the 4, but because we have the 4 factorial in the bottom, we're going to go ahead and get rid of it, so it becomes a 3 factorial. Negative 1 to the n plus 1 doesn't change, so we have this as a constant. N plus 2 is also a constant. N is what we're taking the derivative, x to the n is what we're taking the derivative of, and we have an n factorial. So I'm going to go ahead and at the same time, when we do nx to the n minus 1 divided by n factorial, we're going to go ahead and change that to x to the n minus 1 over n minus 1 factorial. Okay, so we want the first 3 terms in the general term, so our first 3 terms we have 3 minus 4x plus 5x squared over 2 factorial. Our general term for this derivative is going to be this negative 1 to the n plus 1 times n plus 2 times x to the n minus 1, all divided by n minus 1 factorial. Okay, so we took the derivative. Now it says let k of x equal the integral from 0 to x of f of t. Write the first 3 terms and the general term for k of x. So what we're going to be doing now is taking the antiderivative, the integral of each of these terms. So k of x equals. So we want to remind ourselves to look back at the original equation, so 3x. So the antiderivative of 3x, we add 1 to the exponent and divide by it. So we have 3x squared divided by 2. We have 2x squared, and it's minus. So we have 2 times x cubed over 3 plus. We have 5x cubed, so we have 5x to the 4th divided by. Okay, so we have 3 factorial already there, and we are multiplying it by, or we're dividing it by 4. So we're going to be multiplying 3 factorial and 4 together. Minus 6x to the 5th divided by 4 factorial, and we're dividing by 5. And that's going to go on until we get to this here. So reminders, negative 1 to the n plus 1, n plus 2, and n factorial are all constants. So those are going to stay in our equation for now. And we're going to simplify some stuff, but those all stay. Okay, x to the n. So we add 1 to our exponent, and we divide by that exponent. And it goes on forever. Okay, so now that we have this, we're going to go ahead and simplify what we have. Okay, 3x squared divided by 2 doesn't change, so we're going to leave it as 3x squared divided by 2. 2x cubed divided by 3 doesn't change, so we have 2x cubed divided by 3. Okay, 5x to the fourth, that's fine. We have 3 factorial times 4. 3 factorial is 3 times 2 times 1, and if we multiply it by 4, then we have 4 times 3 times 2 times 1. That's the same thing as 4 factorial, so we have 5x to the fourth divided by 4 factorial. 6x to the fifth divided by 4 factorial times 5 would be 5 factorial. Okay, our negative 1 to the n plus 1 is that sign changing, so that's going to stay there. We didn't change anything with the coefficient that was already there, so the 3, the 2, the 5, and the 6. So n plus 2 stays the same. We even keep x to the n plus 1 because we don't have any other x's to multiply with it or divide with it. Okay, on the bottom we have n factorial times n plus 1. So what that means is the opposite of what we would normally do, which is separate it, we're now going to combine them. So n factorial times n plus 1 would be n plus 1 factorial, because that would be n plus 1 times n minus 1 times n minus 2, which n factorial takes care of, except for that n plus 1, which we are now multiplying by. And it goes on forever. So we need our first 3 terms, our first 3 non-zero terms. So we have 3x squared over 2 minus 2x cubed over 3 plus 5x to the fourth over 4 factorial. Okay, I cannot stress enough that if it wants the first 3 terms, you only write down 3 terms. If you accidentally write more than 3, your answer is now wrong. Okay, our general term is what we wrote here. So negative 1 to the n plus 1 times n plus 2 times x to the n plus 1 divided by n plus 1 factorial. So when we take integrals, just like derivatives, we're wanting to look at each individual term and try our best at integrating each term. Because a lot of these are going to be polynomials, a lot of times we're just going to be using power rule, so it makes it a lot easier, and the worst thing is going to be those coefficients and kind of simplifying them.